Okay, so we have some kind of sinusoidal wave, either a sine or a cosine. So whatever it is, it's got some kind of up and down shape like this that goes on forever in both directions. And they're saying, which of these parameters could you change if you wanted to affect the domain, range, etc.? So, domain. Well, the domain for any kind of sinusoidal wave is x is an element of the real numbers. Every value is covered, and this is not going to change if you stretch the wave or if you move the wave 5 feet to the right. These waves are infinitely wide, so nothing you can do will affect their domain. There is no parameter that you can change that will do anything to their domain. Range is another matter. The range for a trig function is from the top of its peaks to the bottom of its valleys, and there's two ways you can change those. Changing A, the amplitude, can make your wave taller and shorter, so it makes your peaks higher and your valleys lower. And also changing the D value changes the vertical translation, so that moves the entire wave up and down. So altering either A or D will do something to your range. The amplitude is all about A. The amplitude is the measure from the midline of your curve to either the tops of the peaks or the bottoms of the valleys. That's always A. The period, you remember, is 2 pi divided by B. So B is the only parameter that does anything to the period. And the zeros, I actually have zeros on this graph. What could you do to this wave that would change the locations of those zeros? As it turns out, virtually anything. Changing the amplitude can make those zeros happen more often or less often. If you cut the amplitude a lot, you could even make there be no zeros whatsoever. So A can affect the zeros. B changes how close together these are, so that would definitely affect the zeros. C translates the entire wave left and right, that could affect the zeros. And D, again, can either cause you to have more zeros or less zeros, or none at all if you slide this wave down far enough so it never touches the x-axis. Now, state the maximum and minimum values of the functions. If you have a wave, let's say it's down here, they want to know what's the highest it ever gets and what's the lowest it ever gets. Well, remember, these waves have a midline which is always exactly at D. And then the amplitude is how far away it gets from its midline. So the highest that this curve will ever get will be D, whatever that is, plus A. Start at the D level and then go up by A units. The lowest it will ever get is start at the D level and then go down by A units. And B and C are both horizontal things, so they're irrelevant as far as this is concerned. So our maximum value will always be D plus A, start at the midline and go up by whatever your amplitude is. And your minimum value will always be start at the midline and go down by whatever your amplitude is. And finally, determine the range of the function. Now that we've done all this, they say, okay, now that you've got a formula worked out, try it with some real numbers. Well, according to what we just wrote, our maximum should be our D value, negative, I didn't mean D, I meant 4, plus our amplitude of 3. So the maximum this curve ever gets to should be negative 1. And the minimum it ever gets to should be D minus A, so negative 4 minus 3, which is negative 7. So this wave has its midline at minus 4, and from there it goes up to minus 1, down to minus 7, and repeat endlessly. If we have to write that as a range, it should be negative 7 less than or equal to y less than or equal to negative 1, and if you think that ranges should start with y as an element of the reals, I happen to agree with you. So there's our complete range.